Diagram shows a solid cuboid with sides of length x, 3x and y centimeters. The total surface area of the cuboid is 32 centimeters squared. Show that 3x squared plus 4xy equals 16. Hence, show that the volume V, centimeters cubed, of the cuboid is given by this formula here. Find V dx. Verify a stationary value of V occurs when x is 4/3. Find d2v by dx squared and hence determine whether v has a maximum value or a minimum value when x equals 4/3. So I've got the question summarized here. Here's the cuboid then. Show that 3x squared plus 4xy equals 16. Let's have a look at that then. So part A. Part 1. Well, we know the total surface area of this cuboid is 32 centimeters squared. So we've got 6 sides. We've got a 3xy and a 3xy. So that's 6xy plus, and then we've got, that's those two sides. This side here is xy and another xy, so that's 2 xy's. That's 4 of the sides. Now the top and bottom is 3x times x and another one. So that's 3x squared times 2 is 6x squareds. Plus 6x squared. So that's the 6 sides, and that must equal 32 centimeters squared. So what have we got here then? We've got 8xy plus 6x squared equals 32. And we need to show 3x squared, so let's divide by 2 and write the x squared term first. So that's the first one, A part 1. A part 2, and show that the volume is that then. So let's just differentiate then. Part 2. Now the volume, well, we're not differentiating, sorry, we're just going to length times breadth times width. So it's 3x squared times y. So it's 3x squared times y. Now we need to eliminate y. So here, 4xy then is equal to, move the 2x squared over, so it's 16 minus 2x squared plus 4y. Oh, I need a 3. That should be a 3, shouldn't it? Sorry, because divide by 2, that should be a 3. So sorry to correct that then. 4xy then is equal to 16 minus 3x squared. So y will equal 16 minus 3x squared over the 4x, isn't it? I've just moved the 4x from times down to divide. So I can sub this. This can be number 1. This can be 2. So sub 2 in 1. 2 into 1 gives, so the volume then, 3x squared times y, which is 16 minus 3x squared over 4x. Okay, and x will cancel here and here, and we're just left with 3x on top, so it's 48x. So that's 48x on top. 3x times minus is minus 9 x cubes. X cubed over 4. Divide by the 4 here, then we get 12x minus 9 fourths. Split the fraction up, x cubed, which is what we needed to show for the volume, wasn't it? Which was here. Find dv dx then. 12x minus 9x cubed over 4. So part B, I think this is now. So dv dx is equal to, let's differentiate. X goes to 1, 12 lots of. The x cubed power rule, minus 3 comes down to b with the 9 to make 27 over 4 x squared. So there's dv dx. Verify if he has a stationary point at x equals 4/3. So here, dv dx is equal to 12 minus 27 over 4 x squared equals 0 then. Let's find out the value of x. That implies that the 27x squared over 4, I'm writing it down from right to left. I've moved this through the equals and flipped the sign and leave the 12 as is. I've written it down from right to left. So x squared then. Move the 4 up, so it's 48. Move the 27 down. There's a 3 common, so that's 16 over 9. So that tells us then that x is equal to the square root, which is 4/3. The negative solution doesn't apply because we're dealing with x as being a positive dimension, because it's a cuboid, isn't it? And then one of the sides is of length x. So x is 4/3. Yeah, that was C part 1. Now the next part, final part of the question, C part 2, find the second derivative and determine if it's a max or min at 4/3. So part 2, here d2v by dx squared then is equal to, differentiate this, that goes to 0, differentiate this power, the 2 comes down, so it's minus, and it will cancel one of the 2's under there to leave a 2 onto it. X, which equals minus 27 over 2 times 4/3, which is going to be less than 0. So max. So a max, maximum at x equals 4/3. So let's have a look at the question, see if we've answered it all. Find the second derivative and determine if v is a max or min at x equals 4/3.